Find the volume of the described solid S. The base of S is the triangular region with the vertices 0, 0, 1, 0, and 0, 1, which forms this region. Now the cross sections are perpendicular to the y-axis, are equilateral triangles. So what we want to take a look at is the following. So over here we have our three-dimensional look. So here is our y-axis, and you can see it goes all the way from here, as this point is 0, 1, and there's our x-axis that goes to 1, 0, and so here is our region. And so they're asking us to make these cross sections that are perpendicular to the y-axis are equilateral triangles. So that means if I cut here, there's an equilateral triangle. You can see that the base is on the x-axis. Okay, if I again make another equilateral triangle, so you can see all the triangles that you're making here that you would slice for that. So now let's take a look at what that equilateral triangle is going to be. Well, the first thing is that we know that this represents the x-axis. So down here, this represents the x-axis. And so we also know that this is an equilateral triangle. So if we draw that line here, right, so we know that we have this equilateral triangle where this is 60 degrees. May not necessarily be completely drawn to scale. This is 60 degrees, right? And if this is 60 degrees, then this is 30 degrees, and this is 30 degrees. So if it's an equilateral triangle, we know that all sides are equal. And what we want to be able to do is figure out what is the height of this triangle. So how do we figure out the height of this triangle? So here we're going to use trigonometry. So we're looking at this 30-degree angle, and we can see that this h is adjacent to that. So we would then, in order to find this problem, we know that the cosine of 30 degrees is equal to the adjacent over x. Now if we want to solve for the height, then that h equal x times the cosine of 30 degrees. So let's go ahead and continue this, and we'll write this as step 1. So what do we know about the cosine of 30 degrees? Well, we know the cosine of 30 degrees is the square root of 3 over 2. So now h becomes the square root of 3 over 2 times x, because we know the cosine of 30 is square root of 3 over 2 times x. Okay, and so we know that the base of this triangle is x, so we know that the base is equal to x. Okay, but now we can find the area of this equilateral triangle, because we know the formula for the area of a triangle is 1/2 the base times the height. So we have 1/2 times the base, which is x, times the height, which is the square root of 3 over 2 x, and if we multiply that together, we get the square root of 3 over 4 x squared. So now we know what the area of this triangle is. So now that we have this, this is in terms of x, but we want this in terms of y. So we need to take a look at this line here that connects to this particular triangle that we cut in those pieces. So in order to do that, we have this line that's going to connect from this point to this point. Okay, and we know what that is. We know that this represents 0, 1, and we know that this line is this point is 1, 0. So what we're going to do is we're going to write this in terms of an equation. So we just need to see that, because if you notice here, this line is now going to cut, right? That's touching this line, so it's going to give us that that line in terms of y. So remember that y minus y1 is equal to m times x minus x1. Okay, and so what is the slope? Well, the slope is y2 minus y1 over x2 minus x1. Well, depending on which point we choose, we can say that y2 for the second is going to be 1 minus 0 over 0 minus 1. And so therefore we get the slope of -1. And now we're going to plug it into our point so we can pick our first point. So it's y minus 1, which is equal to -1 times x minus 0. So we have y minus 1, which is equal to -x. And therefore y is going to equal 1 minus x. Okay. And now again, because this needs to be in terms of y, what we're going to have to do is now solve for x. So if we solve for x, we're going to get x, adding x to both sides, we have x plus y equals 1, and therefore x is going to equal y minus 1. Okay, so now we're going to take this x, and then we're going to substitute it into what we found into the area in that particular equilateral triangle, which is the square root of 3 over 4x squared. So in step 4, we have the square root of 3 over 4, and we're plugging in for x 1 minus y squared. And so therefore, we would say that the area in terms of y is going to equal the square root of 3 over 4. Now, if we square this, then we're going to get, this is a perfect square trinomial, so we're going to get 1 minus 2y plus y squared. So now that we've done that, now we want to find the volume of ay dy. And now what are the values of our lower and upper bounds? Well, you can see here that here is, since we're doing it in terms of y, well, we know that the lower bound is 0 and the upper bound is 1. So therefore, we're going from 0 to 1. So now let's go ahead and find the volume. We're going to factor out the constant, which is the square root of 3 over 4, going from 0 to 1, of 1 minus 2y plus y squared dy. And so now let's go ahead and then find the antiderivative. So we have the square root of 3 over 4 times y minus, that would be 1 over 2. So that 1 over 2 becomes 1, so this is y squared plus 1 over 3y cubed, and then we're evaluating it from 0 to 1. Okay, now let's go ahead and evaluate this. So we have the square root of 3 over 4. We plug in 1, we get 1 minus 1 squared plus 1/3 times 1 cubed minus 0 squared plus 1/3 times 0 cubed. We know that this is going to give us 0. So now let's go ahead and then add here. So we have 1 over 1, or 1 minus 1, which is going to, 1 squared, which is going to give us 0. And then we have 1/3 times 1, which is going to be just 1/3. And so therefore the volume is going to be the square root of 3 times 1, which is the square root of 3, over 4 times 3, which is 12. And therefore the volume is the square root of 3 over 12.